7,000 times 10 to 15 electrons flow through a wire in 14 nanoseconds. Determine the value of current. First, you have to write everything whatever is given and what we're supposed to find. We have number of electrons, 7,000 times 10 to 15 electrons, or making the long number shorter, you can simply write this is 7 times 10 to 18 electrons. We have time, 14 nanoseconds, very short time, and we have to find current. I'm going to use these two formulas. Someone is going to ask why you have to use these two formulas. Because first formula is for current. I'm looking for current. Current is equal charge over time. But I don't have charge. There is formula for charge which says number of electrons divided by 6.25 times 10 to 18 electrons per coulomb. I have given number of electrons. I have given this unknown. This is my constant, so I can very easily calculate the charge. That's why I'm using this formula. So let me write the formula first. Remember, always write the formula first. Number of electrons over 6.25 times 10 to 18 electrons per coulomb. So I'm going to have number of electrons. I have 7 times 10 to 18 electrons over 6.25 times 10 to 18 electrons per coulomb. Electron and electron will cancel out and we will get the value of 1.12 coulombs. This is the charge which is going to go in the wire in 14 nanoseconds. Next, we're supposed to find the current. Formula for current says current is equal charge over time, where charge we found is equal 1.12 coulombs over time 14 nanoseconds. 1.12 coulombs divided by 14 nanoseconds gives you 80 mega amps. This is pretty high current. And this is the solution to my problem.